Okay, for this question, you would write down the characteristic equation as 3r squared minus 5r minus 2 equal to 0. And I think if I multiply 3 and negative 2, that's negative 6. And if I look for two numbers that multiply to negative 6 and add to negative 5, which is the middle one. By the way, this is something that you learn in pre-calculus called factor by grouping method. So you multiply these two to get negative 6 and bring this number down, and you're looking for two numbers that multiply to negative 6 and add to negative 5. What are those?
Negative 6 and 1.
Negative 6 and 1, right? So once you get a hold of these numbers, what you do is you split this middle one into negative 6r and 1r. So you rewrite this as 3r squared minus 6r plus 1r minus 2 equal to 0. And that's when the factor by grouping kicks in. You group the first two, you group the second two, and you factor each of them separately. So this has common factor 3r, so I can factor out the 3r. And then it's r minus 2. This one, there's no common factor, so you just write it as r minus 2. And then you now see a common factor after the grouping, which if you factor out r minus 2, you get 3r plus 1, r minus 2. Therefore, you get r equals to negative 1/3 and 2. Now, if you think this method is too hard, then you can always go for the quadratic formula. I mean, the upside of quadratic formula is that it always succeeds. See, sometimes you can't solve by a factor by grouping. It's like it doesn't always work. So sometimes that might be a better strategy. Okay? But it's not too hard to check. Just multiply these two. Just think about two numbers which will satisfy it. If it does satisfy, then you can go for this problem. If it doesn't, then you're stuck with the quadratic formula. Okay? All right, so let's just say you found this solution regardless of which method you used. What's really important is getting there. And once you get there, then you can rewrite the solution. You can write down the solution as C1 eats the negative 1/3 x plus C2 eats the 2x. Or vice versa. You can switch these two around. It doesn't change the answer. Okay? Now this is not the end of it, because now we have initial conditions, right? So you have to apply it. What's y of 0? Y of 0 means C1 eats the 0th power, C2 eats the 0th power, which is a C1 plus C2. But because y of 0 is given as 1, I know that 1 must equal to C1 plus C2. So this calculation takes care of the first condition. Now let's think about how we handle this one. This is y prime of 0. So what you need to do is you have to differentiate this and then plug in 0. So let's see. Y prime of 0 means you have to differentiate this function, and after differentiating, you have to plug in x equals to 0, right? This symbol here means you plug in whatever that's after it after you differentiate, okay? And if you differentiate this by the chain rule, negative 1/3 appears in front. 2c2 e to the 2x appears. And then you have to plug in x equal to 0. So you end up with negative 1/3 c1 plus 2c2 equals to y prime of 0, which in turn is equal to negative 2. That means you have the following system of equations. First one says c1 plus c2 must be 1. The second one says negative 1/3 c1 plus 2c2 must be negative 2. How do you solve a system? Well, there are many ways. One way is to solve for C1 or C2 and plug it into the next one. Slightly faster one is to multiply this by 3, so that gives you negative C1 plus 6C2 equals to negative 6. And then these two get added up. If you add these two, you get 7C2 equals to negative 5, which gives you C2 equals to negative 5 over 7. Okay. And then when you plug this in over here, C2 is negative C1 minus 5 over 7 is equal to 1, leaving C1 as 1 plus 5 over 7, which is same as 12 over 7. Okay. Now you shouldn't stop here because those are just values of C1 and C2. We're looking for the solution of the original equation, right? So what's the final answer? Answer is y equals to what? 12 over 7 e to the negative 1/3 x plus, or minus actually, minus 5 over 7 e to the 2x. So that's the final answer.